Ever wondered why things at the smallest level don't behave like the larger world we see around us? Welcome to the realm of quantum mechanics, a theory that challenges our understanding of the universe. It's the science of the extraordinarily small, where the rules of classical physics that we're accustomed to just don't apply. Here, particles can exist in multiple states simultaneously, like Schrödinger's infamous cat that is both alive and dead until observed. This isn't a mere thought experiment. It's a fundamental aspect of quantum mechanics known as superposition. Quantum mechanics also introduces the idea of wave-particle duality, where particles such as light and matter exhibit properties of both particles and waves. It's a world where the impossible becomes possible, where the definite becomes indefinite, and where certainty gives way to probability. Quantum mechanics may seem abstract and far removed from our daily lives, but you might be surprised how it permeates our existence. So buckle up as we delve deep into this quantum quandary. Imagine you're flipping a coin. It's either heads or tails, right? In the quantum world, it's not that simple. Let's dig a bit deeper into this. Normally, when you flip a coin, it lands either heads up or tails up. It's one or the other, never both. But what if I told you that in the quantum world, that coin could be both heads and tails at the same time? Sounds crazy, doesn't it? But that's the essence of the superposition principle in quantum mechanics. The superposition principle tells us that a quantum particle can exist in multiple states simultaneously. It's as if our coin, while spinning in mid-air, is both heads and tails at the same time. It's not that the coin is flipping back and forth so quickly that it appears to be both. No, it truly is both. This is a fundamental property of quantum particles, and it's what makes quantum mechanics so radically different from the physics we experience in our everyday world. But here's where it gets even more mind-bending. Once we decide to check the coin to see if it's heads or tails, it suddenly becomes one or the other. The act of measurement forces the coin to choose a state. This isn't like peeking at a spinning coin and catching it at the right moment. The act of measuring actually determines the outcome. This is what's known as the collapse of the wave function in quantum mechanics. Before measurement, the quantum particle exists in a superposition of states, represented by a wave function. But once we measure it, the wave function collapses and the particle settles into one of its possible states. So, while in our everyday life a coin flip might seem straightforward, in the quantum world it's a whole different ballgame. The outcomes are not predetermined. They're not decided until we make a measurement, until we choose to look. In the quantum world, outcomes aren't determined until we measure them. A bit like deciding the fate of our spinning coin. What if I told you that two particles, no matter how far apart, could instantly affect each other? Let's dive into the rabbit hole of quantum entanglement, one of the most mind-boggling concepts in quantum mechanics. Imagine two dancers spinning in sync on a grand stage. Even if they move to opposite corners, they continue to dance in perfect harmony, mirroring each other's movements with uncanny precision. This is a rather poetic way to visualize quantum entanglement, where particles become linked and their properties become interdependent, no matter how much distance separates them. Now, let's replace our dancers with tiny particles like electrons. In the quantum world, once two electrons become entangled, their spin states, essentially their dance moves, become interlinked. If we measure the spin of one electron, we instantly know the spin of its entangled partner, even if it's light years away. Yes, you heard it right. The information seems to travel faster than light, defying our conventional understanding of time and space. You might be wondering, how do these particles communicate? The truth is, we don't exactly know. There's no visible thread connecting them, no secret phone line. It's as if the universe has its own mysterious choreography, a dance that is perfectly coordinated and instantaneous. But don't let this idea of instant action fool you into believing in telepathy or faster-than-light communication. The information transferred isn't something that can be used to send messages or break any cosmic speed limits. It's more like a perfect correlation, a cosmic dance choreographed from the moment of entanglement. Einstein famously referred to this as spooky action at a distance, and it's easy to see why. Quantum entanglement challenges our everyday understanding of the world, pushing the boundaries of what we consider possible. So, while it may seem like the stuff of science fiction, it's a very real aspect of the quantum world. This spooky action at a distance, as Einstein called it, is another mind-bending aspect of quantum mechanics. So, why should you care about quantum mechanics? Well, it's closer to your daily life than you might think. Quantum mechanics may seem like a concept reserved for the realm of theoretical physics, but its principles are actually at the heart of many technologies we use every day. Consider modern electronics. Did you know that the transistors that power your smartphone and your computer rely on quantum mechanics? These tiny switches regulate the flow of electricity by exploiting a quantum mechanical property called tunneling. This is where particles, such as electrons, can pass through barriers that classical physics would deem impassable. And it's not just electronics. The field of computing is on the brink of a revolution thanks to quantum mechanics. Quantum computers, currently in their early development stages, promise to perform calculations at speeds that would leave even the most powerful supercomputers in the dust. This is all thanks to the principles of superposition and entanglement, allowing these quantum machines to process vast amounts of data simultaneously. Moreover, research in quantum mechanics can lead to advancements in other scientific areas, such as material science and medicine. For instance, quantum mechanics could potentially revolutionize drug discovery by enabling simulations of molecular interactions at an unprecedented level of detail. Quantum mechanics may be strange and counterintuitive, but it's also incredibly powerful and holds the key to future innovations. So, while it may seem like an abstract concept, quantum mechanics is shaping the world around us in surprising and exciting ways. It's been a whirlwind journey through the quantum world, hasn't it? We've plunged into the mind-bending concept of superposition, where particles exist in multiple states simultaneously. We've unraveled the enigma of entanglement, a phenomenon so mystifying, Einstein himself dubbed it spooky action at a distance. And we've seen how these quantum quirks shape our everyday lives, from the technology in our pockets to the stars in the sky. As we continue to delve deeper into the quantum world, who knows what fascinating discoveries await us? The quantum world is strange, but it's also incredibly exciting. Before we say goodbye, we have one last request. If you've enjoyed this journey through the quantum world as much as we have, please don't hesitate to show your support. Like and share our YouTube channel, and don't forget to hit the subscribe button too. It's your support that helps us grow and continue to bring you fascinating content like this. Let's keep exploring the quantum world together. Thanks for watching our YouTube channel at Mechanical Wala. Make sure to stay tuned for more mind-bending scientific explorations.